Good morning to all the students. I am Shubhangi Gondane from Mechanical Engineering Department, and today we study about the ADC and DAC system. The ADC means analog to digital converter and DAC means digital to analog converter. The part A and part B, that is part 1 and part 2, these are the two parts of this presentation. So today we start with part 1. The part 1, that is the analog to digital converter. It contains the definition why we need the DAC, the types of ADC and each basic operation, the application of analog to digital converter. So definition: an electronic integrated circuit which transferred a signal from analog to digital form. The analog signal are directly measurable quantity. The digital signal may have two states. For digital computer we refer to binary state 0 and 1. So the heart of the computer base the data acquisition and usually the analog to digital converter. Basically this device is digital voltmeter. The digital system requires the digital data. For example, the analog data goes to the digital and digital gives the digital systems. The digital computer required a signal to be digital from whereas most instrumentation transducer have to be output signal in an analog form. The ADC conversion is therefore required at the inference between analog transducer and the digital computer. So these are the various examples which is related to the voltmeter. The voltmeter, it can be refer the measurement, that is 7.77 volt, and with respect to the cell phone the signal can be measured with in the form of the waves. Why there is a need of ADC? The microprocessor can only perform the complex processing on digital signals. When the signals are in digital form, they have a less susceptible to the deleterious effect on additive noise. The ADC provides a link between the analog world of transducer and the digital world of signal processing and data handling. The types of analog to digital converter. There are many different types of analog to digital converter. Each efforts a something in a way, that is speed, cost, power, dissipation and complexity. The counter type, successive approximation. There are many types such as the flash type, sigma delta, but we will cover in these two types. The counter type. One of the simplest type of analog to digital converter is a counter type ADC. The input signal of ADC is connected to the signal input, its internally compressor. The ADC then systematically increase the voltage of the reference input of the comparator until the reference becomes larger than the signal, and the comparator output goes to 0. For example, consider a input signal is 4.78 volt. The initial comparator input will be 2.5 volt. The comparator compares the value, the result is less than 4.78, then the text to high voltage is 5 volt is applied. The comparator compare the two values and say that this value is greater than 4.78 and switch off the system. The digital output of DAC is the number of times the DAC increase the voltage after starting at an initial position, that is 2.5 volt. This scheme is relatively simple, but as the number of DAC increases, the time it takes to scan all the possibility value, lower input will be go quickly. The compound of the counter type. This type of the counter uses some types of the compound and its operation. The counter type contain the following element, that is digital to analog converter, some types of countering mechanism, comparators and clock. The use of the index in the counter. The DAC to generate the analog signal to compare the against input. Comparator is used to compare the voltage input and voltage DAC, where the voltage input is a signal to be digitized. The output or input to be DAC is the form of the counter. The operation of these counter, that is a voltage input. The comparator can be attached in this way. The control logic can be goes here. Here we start the button. That control logic can be control with respect to this clock, and this can be goes to the counter, and counter can gives the digital output, and these feedback of the DAC can be again goes to the comparator. The operation of the counter can be carried out with this way. The first, there is a comparator, counter logic, clock, counters and DAC. The successive approximation. A successive approximation register SAR is added to the circuit. Instead of computing the binary sequence, these registers count by trying all the values of the bits starting with the MSE and finishing at the LSB. The register monitor the computer output to see if the binary count is greater or less than the analog signal input and adjust the bits accordingly. The SAR architecture mainly uses the binary search logarithm. The SAR ADC consists of fewer blocks such as one comparator, one DAC digital to analog converter and one logic unit. The algorithm is very similar like say searching a number from the telephone book. How the successive approximation is worked. For example, the analog input 6.4.28 volt reference is equal to 1000 volt. Then MSE, that is a main side block, that is a 500 volt, 2SB, 3SB, LSB. So these conditions can be satisfied, then it goes to the 1. These conditions are false, then it goes to the 0 and the system can be on or off. The application, the scanner. When you have scanned the picture with a scanner, what scan is doing is analog to digital conversion. It is taking analog information provided by the picture light and converted into digital. Recording a voice. When you record your voice or use a VIP solution on your computer, you are using an analog to digital converter to convert your voice, which is analog into digital information. Part 2. So part 2 is digital to analog converter, and these can be studied in your next class. Thank you.